All right, welcome back. In this session, we're going to implement the player movement. To do that, we're gonna use Unity's transform.Translate method. Here's a description that I brought up from the Unity documentation. Here it says that transform.Translate moves the transform in the direction and distance of translation. And translation is a vector 3. What a vector 3 is, it's a 1x3 array, and that means that it contains 3 separate values, and each value is going to represent the distance that you want the object to translate in the x direction, the y direction, and the z direction. Okay, so let's go back here. Also, we see here's another description: moves the transform by x along the x-axis, y along the y-axis, and z along the z-axis. So when we pass in the vector as a parameter to translate, it's going to include 3 values, and each of those values represents the amount of distance that we want the object to translate in the x, the y, and the z directions. Let's go into Visual Studio and let's implement this. Let's implement it once. In order to do that, we're going to use the start method. Start, again, remember, is implemented at the very start once this game starts, and it runs only once. We're going to use transform, and the reason we're using the lowercase transform is because we're applying it to this script's object. Then we say translate. So this is saying, hey, for this object, okay, and again, from an earlier article, we explained that transform is a monobehavior property, okay, and that refers to the object for which this script is attached to. Okay, so for this object for which this script is attached to, apply the translate method. And in order to use the translate method, we have to pass in a vector 3, okay, and the vector 3 has to have 3 components: the distance that I want the object to move in the x direction, the distance that I want the object to move in the y direction, and the distance that I want the object to move in the z direction. So let's run this in the game. Let's see how the object behaves. So let's jump into Unity, and here we have our player. We expect that once we hit play, the object, again, we're running transform.Translate only once. So this object is going to move to the right 1 unit, and no more, no less, and that's all it's going to do. It's going to move once, and then it's going to stop. In order to get a sense of what 1 unit is, notice that the scale on the player object here, the scale is 1 unit in the x direction, 1 unit in the y, and 1 unit in the z. This is a cube. And when you look at this cube is 1 unit wide. And so we're telling the script to move our object 1 unit to the right. So when it moves to the right, we should see that it should line up perfectly with where the block used to be. In order to visualize that, I've created this object here, and I've moved it up 1 unit so that once the object moves, we can see. Let's go ahead and hit play, and we should see the block, the player object, line up right up underneath our visual reference. Okay, and there it is. The block moved over 1 unit, and then it stopped. And that's because that's all we told it to do. So that gives us a better sense of how transform.Translate works and how the input parameter, which is a vector 3, modifies that translation behavior. Now, if you notice, if we're supposed to implement this, if we're supposed to run transform.Translate every frame, we just saw that within the span of just 1 frame, which happens in a fraction of a second. If we're trying to run this frame by frame, 60 frames a second, then this object would disappear off the game view. Let's go ahead and run that in in the update method so we can see what we're talking about. And I'm going to comment this out so it doesn't run. And we're going to run it in the update method. And what we should see is that the object, once we hit play, the object just disappears off the screen. Might see it for a little bit here in the scene view, but it'll disappear from there as well. So it really took off. That's too fast. In order to modify that behavior, let's go back into the start method. What we need to do is that here, we're going to multiply this by time.delta time. And let's look at the Unity documentation on time.delta time. Here it tells us that time.delta time is the interval in seconds from the last frame to the current one. You know, when you're running a game, the frame rate is fluctuating from one moment to the other. But since we're only running this once, this is telling us that we multiply the vector 3 by time.delta time. This 1 is being multiplied by 0.017. And that's how much time lapses between frames. Since we're, if you divide 1 second by 60, you get 0.0167. So in 0.0167 seconds, we're essentially multiplying this 1 by 0.0167. And so we're only going to move one fraction of a unit when we run this. So let's run it. Okay, and I don't know if you saw that, but the block barely moved. Okay, it's almost imperceptible by how much it moved. Let's go ahead and implement this in update. And now what we should see, let's go ahead and delete it here from start. Now when we run this, we should see that the block just continues moving to the right without stopping. But this time it's going to do it at a much slower rate. What we see here is that inside of update, the object is being translated by 1 unit to the right, but it's not 1 unit per frame. It's the distance multiplied by the time increment. So it's essentially moving 0.0167 units to the right every frame. That's essentially what's happening here. What we want to do at this point is implement horizontal input as a parameter to translate. What that's going to do is that, remember, what's horizontal input giving us? Horizontal input is giving us a range from 0 to 1 for right arrow input, and from 0 to -1 for left arrow inputs. When there is no input, horizontal input is just 0. And that's what we want. We don't want our object to translate when the horizontal input is 0. When the horizontal input is 0, we want this vector 3 to be 0, 0, 0. When the right arrow is entered, the output value, as we saw in the previous video, is 1. And in that case, we want the horizontal input to be 1 multiplied by the 1 inside this input parameter. Let's go ahead and put horizontal input. We're going to multiply this vector 3 by horizontal input and by time.delta time. And what that's going to do is that when there is no input, we're essentially this horizontal input value variable. When there is no input, this horizontal input variable is 0, and that 0 is multiplied to all 3 components. So then we end up with 0 times 1 is 0. And so then at that point, there is no translate, there is no movement. But when horizontal input is 1, then we multiply 1 times this component. And so we end up with 1, and that we get the translation effect that we desire. Now, when we run it this time, remember, it's not going to do anything until we hit the left or right arrow key. And as we do that, let's look at the horizontal input from our keyboard. Okay, so when I enter the right arrow, okay, we see that the object is moving to the right as the horizontal input is 1. Horizontal input goes to 0, object stops moving. When I click the left arrow, we get -1, and the object is moving to the left. All right, great. So we get horizontal movement. Let's put in a variable for the speed so that we can control the speed a little more. Right now it's moving a little slow. So let's create a private float variable called speed. We'll serialize it so that later when we change it to a private, then we can still see it. But for now, we're going to make it a public float. That way we can tweak it inside the game until we find the right speed value. And then we'll go ahead and set it to say 3.0f. F means it's a float. Anytime you declare a float, when you define the value, you have to append that value by f. You have to append that value with an f. Okay, let's save it. And then also let's go in here and multiply the input parameters by the speed variable. Okay, now we should be able to control the player object and have it move a little bit faster this time. Okay, and here we see that it is moving faster. Our speed variable is a public float. Let's try 7. See how that feels. Yeah, I think that feels just about right. And let's do a little bit more. Let's go with 8. Okay, so we'll go with that. Now inside our player test class, we're going to update this to speed is equal to 8.0f. And then we'll go ahead and make this a private. And it's a private, but it is serialized so that we can see it inside the Unity editor. Okay, so now we can transform, now we can translate the object in the game in the horizontal direction. Let's apply this to the vertical as well. We'll copy this, paste it, and let's change the parameters for this. Here, we want the object to move in the Y direction only. So for X, we'll put 0. For Y, we'll put 1. And then here, instead of using the horizontal input, we'll use the vertical input. That will give us the outputs for the vertical keyboard controls. Everything else is the same. Okay, and my apologies for the switch around. Hopefully that wasn't too jarring. I went ahead and moved everything so we can see everything in one screen. So let's go ahead and run this. Okay. Now, this still feels a little slow. Oh, and that's because, let's stop running the game. That's because the speed didn't update in the script. So let's hit reset. And now we see that the speed has updated. Let's run it again. Okay, there's a horizontal and vertical. Okay, great. Let's refactor this a little bit so that It's good practice to take lines of code that have a specific purpose or function and to create a separate method outside of update. What we'll do is that we'll create a method, and then inside of update, we'll call the method once. And then every frame, when that method is called, that method will execute everything inside of it. So type void move player. Okay. And inside of move player, we'll run the transform.Translate commands. And then inside of update, we'll call move player. Okay, that keeps the update method real clean. And then every frame inside of update, every frame, move player is called every frame. And then every time move player is called, it executes everything inside of that method. Okay, so I believe that covers everything for player movement. All right, thank you for watching.